हेलो दोस्तों, यांत्रिकी के नए वीडियो में आप सभी का स्वागत है। मेरा नाम है प्रकाश त्रिपाठी और आज बात करेंगे बोट एंड स्ट्रीम के प्रॉब्लम्स की। वो स्टूडेंट्स जो कैंपस प्लेसमेंट, स्टाफ सिलेक्शन कमीशन, बैंक, कंबाइंड डिफेंस सर्विसेज या फिर एनडीए के एग्जाम्स दे रहे हैं, उनके लिए बहुत ही ज़्यादा इंपॉर्टेंट टॉपिक है। सबसे पहले मार्क कर लेते हैं 2 पॉइंट्स। देर इज़ दिस 1 पॉइंट ए एंड देर इज़ दिस 1 पॉइंट बी। जानबूझकर पॉइंट ए को ऊपर बनाया हुआ है और पॉइंट बी को नीचे बनाया हुआ है। नाउ लेट अस कंसीडर कि इन दोनों पॉइंट्स के बीच में एक नदी बहती होगी। लेट अस कंसीडर दैट दिस इज अ रिवर दैट फ्लोज बिटवीन पॉइंट ए एंड पॉइंट बी। नाउ इफ सपोज वी हैव अ बोट, देयर इज अ पर्सन हु इज ड्राइविंग द बोट एंड द पर्सन विद द बोट wants to go towards point B. The assumption is that there can be two things. One is the speed of the boat in still water and the speed of the stream. When there is a still water, let us consider speed of the boat as x kilometers per hour. Let us consider that the speed of stream is y. So if I have to like mention in this picture, what I will write, if suppose this is the speed of the boat, which is say x, and then if we consider the speed of the stream in this direction, we consider it as y. Now जैसा कि मैंने आपको स्टार्टिंग में ही बताया था कि मैंने A पॉइंट को ऊपर और B पॉइंट को नीचे बनाने के पीछे का रीज़न ये है कि एनी टाइम द y thing, the speed or the direction of y, the direction of the stream will remain constant, will remain same throughout the problem. So try to understand that this is something which is not going to change. So the y thing, it is not going to change. I'm writing it here, not changing. This is not going to change, neither in terms of direction nor in terms of magnitude. दोनों में भी इसके बदलाव नहीं होगा. But now try to understand, when the person with the boat reaches point B, if now he wants to go back to point A, ऐसा होगा, person started at point A, moves to point B, now from point B he wants to go back to point A. Wants to go back, in that case he will have to change his direction like this. उसको अपने डायरेक्शन को बदलना पड़ेगा. But when he is going back, at that time also the magnitude and the direction of the speed of the stream will remain constant, that is y, and the direction will also not change. Now what we understood is that when the person wants to go from point A to B, at that time the boat direction is this, and the direction of the stream is also this. But when he wants to move in opposite direction, that is from point B to point A, the direction of the boat will be this, but the direction of the stream will not change and will remain in the same direction. We get two conditions, that is from point A to B and from point B to A, आना और जाना वापस. This condition is called as downstream condition and this one is called as upstream condition. When both speed of boat and speed of stream are in same direction, I will call it as downstream, and when the boat is going back, that is against the flow of stream or current, then this is called as upstream. So I feel that this part is clear. Now let us see with the help of a diagram what exactly happens. So here are two conditions. I feel downstream is clear to you. Here you can see we have mentioned the direction of both, and upstream is also clear. We have given you the direction of both. So in first case, पहले केस में x plus y km/h is the relative speed, and in this case x minus y is going to be the relative speed. This is very much different to what we consider in case of trains. In case of trains, when the directions were same, we used to subtract. I have already made videos on trains. Those who have not seen that video, I request you to go and watch the trains problem and then relate it here. In this case will be x plus y, and the speed in upstream case will be x minus y, and here lies all the concept. If you didn't understood anything, at least remember that in case of downstream we have plus sign, and in case of upstream we have minus sign. So to remember this more easily, I'm writing here d plus u minus. This is what you have to take from here. D plus u minus formula will act. So what it says, D is for down. Whenever it is down, speeds will get added up. Whenever it is upstream, speeds will be subtracted. So now let us directly move to the problems. The question says, a sailor goes 8 km downstream in 40 minutes and return back in 1 hour. Then the speed of sailor in still water and the speed of current is. For solving this problem, let us start. Distance is 8 km. And now let us suppose that there are 2 points A and B. The sailor is somewhere here with his boat, and speed of boat I will consider as x, and the speed of stream I will consider as y. Now it says that it is going downstream. So for downstream case, speed is equals to x plus y. What is the distance that he has to cover? It is 8 kilometers. And what is the time that it is taking? It is 40 minutes. Now it says that and it returns back. Obviously the returning back will be upstream. So here you follow. This is the direction of stream now, and now suppose the sailor is here and he now wants to go back. So this will be the direction. This is x and this is y. Now for upstream case, I will write what data we have. S is x minus y. Distance is again same 8 kilometers. And what is the time taken now? The time taken here is 1 hour. So you can see very clearly that time here is given in minutes, whereas in this case it is given in hour. We will do 40 divided by 60, that is 40 minutes divided by 60 minutes to convert it in terms of hours. So it's a simple calculation. You can easily get 2 by 3 hours here, and here it is 1 hour. It is perfectly okay. So the basic equation is time is distance divided by speed. I am going to use this equation in both cases. My time here is 2 divided by 3. It is 8 upon x plus y. This is the case for downstream, and for upstream it will be 1 is equals to 8 divided by x minus y. We get two equations. All we have to do is to solve these two equations. So let me solve it for you. We have 24 is equals to 2x plus y, and x plus y is equals to 12. Similarly here we have x minus y is equals to 8. Now solve these two equations. So if I solve these two, so you will get x is equals to 10 km per hour, and the value of y will be 2 kilometers per hour. So I hope you understood this question. Let's move to question number 2. A boat goes 70 km in 10 hours along the stream and return back the same distance in 14 hours, then the speed of boat and the stream is. So now I am not going to draw any diagrams. Now we will try to make it a bit fast. We know the formula that okay, time is equals to distance divided by speed. We have two cases. One is for downstream, other is for upstream. So time is 10 hours that is required. In case of downstream, 10 hours are required. So time I'm putting 10 hours. The distance we have to cover is 70 kilometer. And now we know that whenever we are going downstream, we have speed is equals to x plus y. So I will put it here, speed is equals to x plus y. In case of upstream, the time taken is 14 hours and the distance remains same, 70. We know that in case of upstream, we are doing x minus y will be our speed, where x represents the speed of the boat and y represents the speed of the stream. I will put it here, x minus y. So now again I have two equations that are to be solved for the values of x and y. So from here I am getting x plus y is equals to 7, and in this case x minus y is equals to 70 divided by 14, that is equals to 5. Now if I solve for x and y, I will clearly cancel out this y's. We will get 2 of x is equals to 12 and x is equals to 6 kilometers per hour. Whereas for y, if we calculate, we will get y is equals to 1 kilometer per hour. And then what is x? X is the speed of the boat. And what is y? Y is the speed of stream. So this completes the problem. So coming to question number 3, speed of a boat in still water is 10 kilometers per hour. So let us say that x is equals to 10 kilometers per hour. That is speed of the boat is given. If it can travel 26 kilometer downstream, so I have this data for downstream and this is the data for upstream. So the distance traveled in this case is 26 kilometers, and for upstream the distance traveled is 14 kilometer in same amount of time. So time in both cases are same. Time is same for upstream as well as downstream. Now what they want us to calculate the speed of the stream. That is, we have to determine the value of y in kilometers per hour. So again we are going to use same concept. Time is equals to distance divided by speed. So in case number 1, when it is downstream, it is 26 kilometers divided by the speed. Speed is x plus y. For downstream, we have understood the concept. It is always x plus y. And now for the upstream case, we have in place of distance, we can write 14 divided by distance is 14 kilometers and speed is x minus y. And the same amount of time is taken in this case as well as in this case. Both the cases, same amount of time is required. So very clearly we have final equations arriving 26 upon x plus y is equals to 14 upon x minus y, because time is same. Also we know the value of x in both the cases. So now the equation will change, and let me make it this way. And then we have only one unknown y for which we have to solve. So let us solve for y. So I have 260 minus of 26y is equals to 140 plus 14 of y. Once we are into this equation, we have 260 minus of 140, that gives us 120, and that is equals to 40 times y. This gives us y is equals to 120 divided by 40, and 3 kilometer per hour will be the speed of the stream. So I hope that you understood the concept of upstream, downstream, boat and stream problems. I am soon going to release the part 2 for this video, wherein I am going to solve few more complex problems. And I believe all of you know what you have to do. You have to like, share and subscribe my channel for more such videos.